let's go over the 8th grade STAR review. This is going to be for your CBA coming up on the 10th. And this is all reporting category 1. So we're going to be finishing out reporting category 1, which means an entire fourth of your work for the year will be done. All right, so notice on the side here we have a Bohr model. We have electrons, protons, and neutrons. The electrons are tiny and negative. The protons are large and positive. The neutrons are neutral and they're also large. They're just slightly larger than the proton, but about the same size. The blank is the positively charged particle of the atom found in the nucleus. That's the proton. The blank is the neutrally charged particle of the atom found inside the nucleus. That is the neutron. And the blank is the negatively charged particle of the atom found in the electron cloud. That's our electron. Up next, A stands for atomic number, P stands for protons, and E stands for electrons. All this means is that the protons, atomic number, and electrons are all the same. So notice we have 6 protons, 6 electrons, and the atomic number for carbon is 6. Let's do man now. Man stands for mass minus atomic number equals the number of neutrons. The charge of a proton is positive. It's located inside the nucleus, and it has a mass of 1 AMU. What about a neutron? The charge of a neutron is neutral, aka there's no charge. Its location is in the nucleus, and its mass is also 1 AMU. Lastly, we have the electron. The electron is negative. The electron cloud it's located in the electron cloud, and it has a mass of negative 1 AMU. Most of the mass of an atom is in the nucleus, and most of the volume of an atom is empty space in the electron cloud. Let's see if I can move this. What is the total number of protons, neutrons, and electrons in an atom that has a mass of 186? To answer this question, you'll need to look at a periodic table. I'll give you a moment. The proton for an atom that has a mass of 186, the number of protons is 75. The number of electrons is also 75, and the number of neutrons is 111. What's the difference in electrons between one atom of potassium K and radon Rn? I'll give you another moment. The answer is 67, because 86 minus 19 is 67. What is used to determine an atom's identity? The number of protons in the atomic number. The atomic number determines an atom's identity. The reactivity of an atom is determined by its number of valence electrons. Valence electrons determine an atom's reactivity. How many valence electrons does magnesium have? Once again, you need to either look at your periodic table or you can count the number of protons, because protons determine the identity of an atom because it's the same number as the atomic number. That's why we say ape, which means A equals P equals E. The atomic number is the same as protons and the same as electrons. How many protons does magnesium have? 12. Now, how many valence electrons does magnesium have? Valence electrons are on the outermost shell. That's this ring on the outside. 1, 2. Valence electrons for magnesium, the number is 2. What about fluorine? 1, 2, 3, 4, 5, 6, 7. Fluorine has 7 valence electrons. Lastly, hydrogen. 1. Hydrogen has 1 valence electron. Atoms with 1 valence electron are the most reactive. For example, lithium only has 1 valence electron. Atoms with 7 valence electrons are the most reactive nonmetals. 1, 2, 3, 4, 5, 6, 7. Fluorine is the most reactive nonmetal. Is one of the most reactive nonmetals. Atoms with 8 valence electrons are stable and do not react with others. 1, 2, 3, 4, 5, 6, 7, 8. Neon has 8 valence electrons. Therefore, it's stable and doesn't react with other elements. There's a rule for filling out energy levels. The innermost ring, that's this one right here, can only hold 2 electrons. The second ring, and that's this one right here, can only hold 8 electrons. And the last energy level, which is the last one right here, with only 1 valence electron, can hold up to 8 valence electrons. Which of these atoms is the most stable? I'll give you a moment. Great job. Argon. Argon is the most stable. Which of these atom models is the most reactive? Metal. You got it. Sodium. Sodium is the most reactive metal of these four elements. Which of these atom models is the most reactive nonmetal? Excellent. Fluorine, because fluorine has 7 valence electrons. Any atom with 7 valence electrons is one of the most reactive nonmetals. Let's continue. Periods are the same as energy levels or the number of rings. So, for example, K, which is potassium, is in period 4. Therefore, the element potassium has 4 rings, aka energy levels. Energy levels is just an interesting way to say rings. Groups, they go up and down. For example, this is group 13. It has boron and aluminum and gallium and a bunch of other elements. Groups determine your properties. All of these elements that are in the same group have similar chemical properties. And guess what? They also have the same number of valence electrons. They have 3 valence electrons. All of these elements have 3 valence electrons. Name the identity group of the period. Lithium is in group 1, period 2. What about this element? It has five protons and six neutrons. Remember, protons determine the identity of the element, so you can use the number of protons to find the atomic number because it's the same. A equals P equals E. Great job. The second element must be boron because it has an atomic number of 5, and the protons are 5. Therefore, the atomic number must be 5. It is in group 13, period 2. Let's do another. Locate an element with 9 protons. Fluorine. Good job. Fluorine's in group 17. That's the column that goes up and down. And period 2. That's the period that goes across, the row that goes across. This is an easy one. We're locating an element with 10 protons. Neon, group 18, period 2. Lastly, locate an element with 13 protons. Great work. It's aluminum in group 13, period 3. Which elements are in the same group based off the atom models provided? Boron and aluminum, because they're in the same group. Group 13. Groups go up and down. Any element in the same group has similar properties and the same number of valence electrons. Let's look at some chemical equations. The little number tells you how many atoms of each element there is. This little number is called a subscript. Which chemical reaction involves the fewest atoms? Remember, you're going to count out each atom. For example, oxygen, there are 3. Nitrogen, there's 1. Oxygen, because there's a coefficient here, is actually 6. Nitrogen, there's 2. Argon, there's 2. If there's no little subscript number next to the element, that means there's only one of that element. Here are the answers to help you out. Let's move on. Evidences of a chemical reaction. The Statue of Liberty was originally a bronze color, and now it's green. The evidence of a chemical reaction is a color change. The way we remember that is C for color, or city. C, city, C, color. Look at the blue substance in the beaker. It's bubbling. We call that gas formation. G for girls. C, city, G, girls. C, color, G, gas. Up next, we have L, city girls love. C, city, G, girls, L, love. C, color, G, gas, L for light. What do city girls love? City girls love their CGLT. What could be a T with a flame? What evidence could that be? Temperature change. Great job. And lastly, we have city girls love their phones. CGLTPO. That's how we remember the evidences of a chemical reaction. There's not an O on this slideshow, but we'll add it in. CGLTPO. P stands for a precipitant formed. All a precipitant is a solid forming from a liquid. Think about leaving milk out. If you leave milk out for too long, when you come back to it, there'll be chunks in it. That's a precipitant formed because a chemical reaction has occurred. Or think about making slime. You take liquid ingredients and then all of a sudden a solid forms. That is a precipitant. And the last that's not logged here is odor. If you get a odor that was not a part of either chemical when you mix them together, that is also a sign of a chemical reaction. Law of conservation of mass. If you notice on the balance beam, the reactant, which is the first part of the equation, it really just more or less means ingredients, is the same as the product. Think final product. In a chemical reaction, the mass of all reactants must equal the mass of products. Mass is neither created nor destroyed, and that's the law of conservation of mass. Physical change can only be physical properties such as size, shape, or phase. So I can melt water. I can melt ice, but it's still just water. I can freeze ice. It's still just water. Those are not a chemical change. I can rip paper, but it's still paper. Freezing, melting, evaporating, dissolving, and boiling, those are all examples of physical changes. A chemical change produces a brand new substance and it has new properties. Think of burning a log or something rusting. Rusting, burning, tarnishing, those are all chemical changes. The body goes through its own physical and chemical changes. Chewing food is a physical type of change. The food gets smaller, but it's still the same kind of food. However, when it reaches your tummy, acids in the stomach break down the food, and that's a chemical type of change. All right, this should be the last one. Blank is the property of a metal that reflects light. Think back to sixth grade. What reflects light? What term did we use? Luster, which just means shininess. Blank is the property of a metal that allows it to be shaped or hammered. Malleability. Being malleable is the property of the metal that allows it to be shaped. Blank is a property that allows electricity to flow through it. Starts with a C. Conductivity. This is for conductors. Blank is the property of a nonmetal that allows things to break. Starts with a B. Brittle. Did you guess it? Blank is the property of a nonmetal that allows things to be dull. Dull luster. And blank has the properties of both metals and nonmetals. It's the green elements on the periodic table. Yeah, metalloids. We're going to skip mass, volume, density because that's more for sixth grade. But if you're curious, here are your answers. All right, so we're going to end here. Make sure you fill out the worksheet that's attached to this video. Thanks and have a great day. Bye-bye.